Hey guys, welcome back to my YouTube channel, The Drone Garage, and today we're going to be looking at a very interesting topic. Back in 2020, when Apple released the iPad Pro and iPhone 12 Pro and Pro Max series, they promoted a very key feature of theirs. If you guessed it right, yes, it is the LIDAR sensor. What is LIDAR? Why am I talking about it? Why am I talking about LIDAR in a drone video? You're going to know why in the next upcoming few minutes.
LIDAR stands for light detection and ranging. They're basically sensors which use light energy emitted from a laser to scan the environment and measure variable distances. A LIDAR system calculates how long it takes for beams of light to hit an object or surface and reflect back to the laser scanner. The distance is then calculated using the velocity of light, so the information got from the sensors is used to build a virtual map of the environment or surroundings. LIDAR is useful when used to create high-resolution digital surfaces, terrain, and elevation models used for various business applications. But how do we integrate this in a drone? A drone is mounted with a LIDAR sensor that captures data from the surroundings and stores this data. It creates these point-like projections on all surfaces it hits and makes a virtual model of the environment. This data is then collected by the drone and is stored. As I mentioned, it sends these point-like projections from the laser it has. This forms a point cloud. A point cloud is a set of data points in space, and each point on the point cloud represents a projection from the laser. These point clouds have X, Y, and Z geometric coordinates. So let me explain this using an image. We can see that the diagram has so many of these projections forming a point cloud, and each point shown is a part of the whole point cloud. We see that these projections form an accurate representation of the building. The drone flies over the building at all different angles and makes these projections in space. Let's look at some of the applications of LIDAR. When an accident happens, especially at night, drones are sent to the site and accurate information about the accident or the crash is retrieved. This data is used for obtaining information for future reference as well as getting an idea of the situation immediately. This really helps in adding detail to understanding and analyzing an accident. Production of some plant-based products require the efficient management of forests. Yet managing these vast areas can be overwhelming due to their sheer size. Traditional methods for assessing a forest inventory are time-consuming and inefficient, at times relying on rough estimates for large areas. Using a LIDAR-equipped drone, foresters can measure canopy heights, coverage, tree density, and even measure the location and height of individual trees. Sounds good, right? By using a method of detecting distant objects, such as leaves, shrubs, trees, and even grass, LIDAR can determine their position, velocity, and other characteristics by analyzing pulsed laser light reflected from an object's surface, which is basically how a LIDAR works. This gives a 3D model of topographic terrain contours that ground operators can work from. On large-scale farms, landscape 3D mapping has become crucial to implementing effective irrigation systems. A LIDAR-equipped drone can collect data in a single pass and allows farmers or consultants to progress through a large field quickly. Previous methods proved cumbersome and would involve waiting for the fields to dry up enough so that trucks could maneuver the terrain. But now, with LIDARs, this has become a whole lot easier. Where traditional surveying methods for large historical sites used to take years to complete, with new LIDAR technology, entire cities can be mapped in 3D and in a matter of minutes, that too. With UAV-based solutions, previously considered lost sites are being rediscovered every day. The GNSS stands for Global Navigation Satellite System. It refers to a constellation of satellites providing signals from space that transmit positioning and timing data to GNSS receivers. The receivers then use this data to determine location. The GNSS receiver is an essential component of the UAV embedded LIDAR. It is used to calculate the geographical position of the system and the precise time at the moment of the transmission of each laser pulse, as well as for the reception of its echo.